Organic or inorganic? That is the question. So we're going to be looking at how forensic chemists distinguish between these two classes of compounds, because when evidence is collected, the fundamental basis is it organic evidence or is it inorganic evidence? And so in the school lab anyway, we do very simple tests to determine that. And so the first thing what you have to realize is, remember that organic compounds are those that are predominantly made of carbon and hydrogen and oxygen with some nitrogen and maybe a little bit of sulfur. So if you think of carbohydrates, carbohydrates are mostly carbon and hydrogen and oxygen. Proteins are organic, but then proteins can have sulfur in them and they can have nitrogen in them, but they're a large proportion of carbon, hydrogen, and oxygen. So they're organic compounds. There's lots of different classes of organic compounds. So we can have organic acids, we can have esters, we can have fats, we can have proteins, we can have carbohydrates, we can have lots of different subclasses. Inorganic compounds are the ones that you most experience in the lab in terms of like ionic substances such as sodium chloride, magnesium hydroxide. You've got sulfuric acid, you've got hydrochloric acid. You know, lots of different compounds fit into that as well, but they are not made up predominantly carbon and oxygen, right? They're inorganic compounds, so in associated elements. And so how can we tell the difference between them? How can we tell the difference between a solution that is sugar, which is organic, and a solution that is sodium chloride? Well, the first thing is we've got to see if they can be burnt. So let's draw up a table, put down some features, and let's compare the two. All right, the first feature we're going to be looking at is the good old Char test. So in the school lab anyway, to find out if a sample is organic or inorganic, we just heat it. And when we heat it, we find out if it chars, that's an indication that it's got organic compounds there. It's got an organic skeleton, if you will. Okay, and so think about wood. When you burn a match, you're left with ash. That ash is an indication that it's got a lot of carbon in there. And if it's not organic, it will melt. Okay, so if you think about you know, heating up an inorganic salt, it just turns into inorganic molten salt. Whereas an organic substance, such as a wax or whatever, will liquefy first, but then it will char, it'll burn. Right, looking at melting point here, you can see that we've got characteristically lower melting points compared to inorganic substances. Now, of course, these are just very broad categories because we can probably all think of different situations in which an organic molecule is going to have a higher melting point than an inorganic. But as a group, when you think about it, organic substances are covalent molecular substances and they have weak dispersion or weak intermolecular forces, whereas inorganic substances can have very strong intermolecular forces. And so characteristically, they've got a higher melting point than a organic substance. But the simplest test, of course, is the Char test. Okay, so once we work out whether it's organic or inorganic, then we can go on to further analytical tests. And we're going to look in the next section of some of the tests we can do to distinguish between the different organic compounds and the different inorganic compounds. And it's like a puzzle that you first of all work out whether it's organic, and then once you know it's organic, then what type of organic compound? Is it an acid? Is it an ester? Is it a hydrocarbon? And so we're going to be looking at those next. Okay, see you in a sec. All right, we're just going to quickly look at these because we're going to, in a separate video, look in more detail in the tests for these. But organic compounds, in the HSC course anyway, we're going to be looking at hydrocarbons, alkanols, and alkanoic acids. Of course, there's lots of other categories that we're not considering, such as esters, such as fats, you know, such as sterols and steroids, and you know, aliphatic compounds, aromatic compounds. We're just going to be looking at these three, okay? And so hydrocarbons we've come across before, and we know that hydrocarbons can be alkanes, right? Characteristic carbon single bonds. Then we have alkenes, characteristic double bonds, and then we have alkynes, triple bonds there. And of course, we've already discussed in the course about how you can characteristically determine between a single bond and a double bond, and that is with the bromine water test. And we're going to be looking at some other tests you can do in the next video, okay? But they're the main groups of hydrocarbons that we're going to be looking at. Then we've got alcohols or alkanols, and that's characteristically where you have an OH group present. And we're going to be looking at tests that you can do to distinguish between alkanols and hydrocarbons. So if you have a clear colourless solution, is it a hydrocarbon or is it an alcohol? What can you do? What tests can you do to determine whether it's an alcohol or hydrocarbon? That's going to be in the next video. And then of course we've got alkanoic acids, which we have our characteristic carboxylic acid group here. And yet again, what test can we do that's going to determine whether it's an alkanoic acid? Because in a test tube, they all look very similar in terms of visual identification, right? Colourless liquids, most of them, right? The lower molecular weight variants. So in the next video, we're going to be looking, if you had a sample of these, what tests could you do to determine between whether it's a hydrocarbon, an alkanol, and then an alkanoic acid? Once you've worked that out, you could go further. Is it an alkane, alkene, or alkyne? If it's an alcohol, well, we can go further. Not in this course, we're not going to, but we can actually classify them into different types of alcohols. We can classify them as a primary alcohol, secondary alcohol, or tertiary alcohol. Okay, so we're not going to get into that, but we can do that. We can do tests and oxidation tests to work out if it's primary, secondary, or tertiary alcohol. So we can be more specific. So we can do those tests in the lab, and we can do tests to classify alkanoic acids. And so in the next video, we're going to look at in a bit more detail what tests we can do to determine between the different classes of compounds, okay, of organic compounds. And then we're going to have another video that's going to look at, well, what tests can we do in the school lab, and how would they do it in a forensic lab, okay? All right, hopefully that makes sense. Pretty quick video, just looking at inorganic versus organic, and then how we can break organic down into the main classes, and that now we're going to be looking at what tests we can do to see if we can get a better understanding of what evidence you have in front of you as a forensic scientist. All right, see you in the next video.